So real briefly in this video, we're going to try to make it brief. We're going to answer these two questions. Why use Kelvin temperature scale? And what is R? Where did this come from? And what are we going to end up using it for? So, first of all, why use Kelvin? So there are two reasons that Kelvin works. And one of those reasons is 0 on the Kelvin temperature scale is 0. There's no argument about it. Well, within a couple significant digits. It's 0. Just call it 0. In other words, when we get 0 kinetic energy right here, we also have 0 as the temperature. So what that really means is there are no negative Kelvin temperatures. No, they're always positive numbers. Oh, that's going to be really important. And second reason is if the temperature doubles in Kelvin, the kinetic energy doubles. Let's look at a graph here of what I'm talking about. If we change the temperature from 0 to 100, the kinetic energy is this much changed. Now, if we just double that temperature, like boing, double it up to 200, the kinetic energy also doubles. Now, that's really important because we're going to be doing calculations where we're looking at the proportional change of temperature, and that's going to cause a change in other properties of the gas. And that has to be in line with what's happening with the kinetic energy. So that is why we have to use Kelvin. That's why it works. Now, the other question for us here is what is R? What is R, other than the pirate's second favorite letter? Do you know what the pirate's favorite letter is? Nah, it's not R. It'd be the C. Okay, so what is R? Well, if you take a volume of gas, and we're just going to call this volume of gas 22.4 liters. Well, we know from other things that we've studied that 1 mole of gas at standard temperature and pressure is 1 mole. We kind of know that 22.4 liters of gas at standard temperature and pressure is 1 mole. Now, if we start playing with those numbers, and that's what people did to discover mathematical laws, was start playing with those numbers and making a little bit of sense out of them. If you take that, pressure and that volume, 22.4 liters, and 1 mole and 273, and you do the math, you're going to come out with 0.08206, or really close to that. Really close to that. That's the number we're going to use for this class. Now, the units are atmospheres times liters divided by moles and divided by Kelvin. You're going to be writing that unit a lot. That's a derived unit for this thing that we call R, the ideal gas constant. Well, why is it a constant? Well, if you take gases and you don't make the pressure too high or the temperature too extremely low, they always follow this pattern. If you take another sample of gas, and this time it's a higher pressure and a lower volume, because if you increase the pressure and you keep the moles the same and the temperature the same, the volume's going to get smaller. And you do the math on that, 0.08206 liter atmospheres divided by moles and divided by Kelvin. It's the same number. But wait, what if we do this? We just use a whole other random set of values that we we have this sample of gas, and we're going to put it under this pressure. We're going to squish it till it's this pressure, and it's 15.6 liters, and we know that we put in 4.3 moles, and we're going to find the temperature is 110.5 because we had to cool it off quite a bit. We had to cool it down to get it to that pressure. Well, 0.08206 is going to be this value when we do that math. So that is the ideal gas constant, and it allows us to relate any of these so that if we know if we know three of these four things, we can calculate the fourth. Oh, that's what we're getting to. Yes, because that is really important for us to be able to do. Like, to look at the fire extinguisher on the wall and know, well, based on its temperature and pressure and volume, how many moles of carbon dioxide are in that container. That's really useful for us to be able to do as an engineer. Are there other values for R? Yes, but you don't need them for this class. Now, if all you change is all you would have to change here, of course, is the unit of pressure, and you're going to have a different value for R. So if for us, the important thing to understand is that if you see kilopascals, we're going to be changing that to atmospheres, because our value for R that we are using on a daily basis has the unit atmospheres in it. If you see the unit millimeters of mercury, you're going to need to change that pressure to atmospheres, because the only value for R we are going to be focused on is 0.08206. That's the unit for R for you. Thank you for listening.